Welcome. It's Thunder Thursday, November 18, 2021. Welcome. Today we're going to discuss how the neutron, the proton, the electron, and the neutrino, how those mass energy vessels hold both mass and energy. We are given that mass and energy are equivalent. And from those four particles, we know that when a proton meets an antiproton, that they annihilate each other and they release energy. But we are not told how that energy is stored permanently inside the proton. The proton has a little bit less than 1 GeV of energy stored inside its envelope. Okay, now what Adoni says, what I say, because I'm Adoni the physics guy, I say that the universe, God created the universe by pumping God particle ones into the universe. Now, a God particle one, we define a God particle one as the tiniest particle of mass in the universe of Planck length. Now, Planck length is an arbitrary number of smallness, tininess, okay? It's 10 to the minus 34 meters, okay? No, it has a more defined number. But it's very small. Now, it wasn't given originally as the tiniest recognizable length, okay? The size, it's very tiny size. So there could be a sub-Planck length particle of mass, okay? So God popped the universe with these GP1s, God particle 1s. And then the universe developed a finite volume, or God kept pumping these GP1s into a finite volume, and then a pressure developed. The God particles develop a pressure, and they developed a spin, and they developed a bounce, okay? And over infinite time, the GP1s hooked up into strands that eventually got woven into strings, and then the strings got woven into permeable sacs, okay? So that the smallest permeable sac of mass that we have equipment to see is the electron neutrino. The electron neutrino is about 1/1,000,000th the size of the electron. Now, they've discovered recently, in the past decade or so, that the neutrinos coming from the sun, that they come in 3 different flavors. That's 3 different sizes, okay? So they call a flavor as a different size. So there's about 1/3 is the electron neutrino, and 1/3 is the muon neutrino, which has like 50 times the mass of the electron neutrino, which is a very tiny mass. And then you have the tau neutrino. So through studies at Snow Lab, it was discovered that the neutrinos that come from the sun, that they change flavors, the mass changes. Okay? But where we're at 1 astronomical unit from the sun, where we're at, the distribution is 1/3 electron neutrinos, 1/3 muon neutrinos, and 1/3 tau neutrinos, approximately. Okay, so we're given that. Now, what I say is that the GP1s, that matter sacs, or matter mass energy vessels, the proton carries both mass and energy. And if you increase the mass of a proton by pumping it up, I say you pump it up with God particle 1s. You compress the God particle 1s inside the proton sac, and that's how you get a more massive proton, a hotter proton. So matter heats up by net imploding GP1s inside the proton sac, the proton envelope. Okay. Now you're told that gluons hold the quarks together. Okay. Now the gluon, the quarks are very tiny relative to the mass of the proton or the neutron. Okay, so and then they're saying that energy contains energy. Okay, they say the gluon is the energy that is the other 900 MeV, 900 MeV of the proton energy is in the form of gluons. Okay, so energy is given as containing energy. Okay, so what I say is that there's a physical component of energy inside the proton envelope, that this physical component of energy takes the form of compressed God particle 1s. God particle 1s are the potential energy permanently stored inside a proton sac and also inside an electron sac and also inside an electron neutrino sac and inside a muon electron neutrino sac. Now, one of the reasons we know this is that if you direct a laser beam, which is phased light at very high amplitude, okay? So you have phased light at very high amplitude. What that means is that the laser light pulsates with an extreme high GP1 pressure, and then it's followed by an extreme low GP1 pressure. Now, the GP1 pressure is relative to the pressure of the universe. Okay? So the farther away you get from matter, the higher the GP1 pressure is. Okay? And you can think of planets, you can think of stars as low GP1 ether pressure systems. Okay? What the Earth does is it pulsates every 26 seconds. We are given the Earth pulsates every 26 seconds. And what it does with each pulsation is it net compresses at different levels. It net compresses GP1s inside nucleon sacs, inside electron sacs, and inside neutrino sacs. Okay? And now let's study gravity and how a molecular hydrogen cloud, a hydrogen-helium cloud, okay? Okay, now we're told that you have a cloud and then under gravity, the cloud collapses on itself. And this is over millions of years, okay? Now, we say that the way gravity is generated is at the center, it's going to be the highest pressure, okay? The higher the pressure, the more you compress a gas, the hotter it gets, okay? So the cloud pulsates, and in a compression pulsation, the center gets hot, okay? But the pulsation carries through farther, and the absolute center gets cooler, okay? And when you extract GP1s, so GP1s make the structure of space. And the structure of space has a certain pressure. There's a uniform pressure as evidenced by the cosmic microwave radiation. So what light waves are, they're compression and decompression, okay? Just like sound waves. Sound waves compress air molecules and decompress air molecules. And then the difference in momentum when they hit our eardrum and our ear follicles and stuff lets us hear. And it's a similar thing with our eyesight, except it's the gaseous particles are God particle ones. So God particle ones hit the rods in our eye, and they create a certain electrical signal, and we can see. And this was over millions of years, the ability to see developed in animals, and that was passed on to humans. So we can see. Okay, so most of the energy, a lot of the energy in the universe is in the cosmic microwave background radiation. Now, another way to think of energy is entropy, okay? So the peak frequency of the cosmic microwave background radiation, the CMBR, the peak frequency, one of them, there are two. One is 280 gigahertz, and the other is 160.3 gigahertz. So I don't know how there can be two peak frequencies, but it depends on the method that you use to compute the peak frequency of the cosmic microwave background radiation. So I do not know all the details of how they come up that there's a temperature throughout the universe. If you point a thermal sensing telescope to any part of the universe, you're going to come up with a temperature of 2.72 Kelvin, okay? And that by one measurement, that translates to a peak frequency of 160.3 gigahertz. Okay, what that means is that, in our view, electromagnetic waves are physical waves of God particle ones. Electromagnetic waves propagate in the medium of electromagnetic waves, which is the God particle one. And that just as life grew from atoms in our oceans over 400 billion, it's 4 billion years, so over 4 billion years, life developed on Earth from atoms, okay? From the atoms that we had and the water that we had and the energy from the sun, we ended up with single cell plants, and we ended up with protein chains, and then we ended up with single cell plants, and we had phospholipids in there. And I say that the same thing happened at the subatomic level. That at the subatomic level, the tiniest particle, the building block of matter at the subatomic level, the building block of matter developed a sac. And this sac was able to hold a certain amount of energy. And that the smallest energy that we can measure is the electron neutrino. And that if you pump more energy, as the electromagnetic energy from the sun can pump up that neutrino 50 times, and it becomes a muon neutrino. And then the tau neutrino, maybe 50 times or more, have more mass than the muon neutrino. Now, back to those electrons. We have electrons, and you shoot a laser beam at those electrons, then you can make muon electrons. I think the muon electron is like 50 times more massive than the electron. Okay? And then it quickly decays. So what we're discussing today is particles that can permanently hold both mass and energy. And that's a very limited amount. the muon electron can temporarily hold 50 times the energy of the electron, but it's a very tiny, less than a nanosecond that the muon can hold on to this energy. Because what happens is when you pump more GP1s, okay, inside an electron sac, okay, you pump it up to 50 times the size of the electron. Well, the woven sac, the openings expand, okay, and the pressure increases maybe 100-fold, maybe 1,000-fold. So the higher pressure inside is going to push out the compressed GP1 is going to push them out quickly. And then it decays to a sustainable amount. Okay, so the electron sac has a sustainable amount of GP1s. Okay? And we are given that the electron mass energy vessel sac at 511 keV, that's kilo electron volts, okay? So they use energy to measure. Now, the reason we know that the electron is a sac, that the proton is a sac, and they're indestructible sacs, okay? The life of a proton, the half-life of a proton is given as a quadrillion times a quadrillion times a quadrillion times a quadrillion years. So I say that since you can't tell the age of any individual proton in my body, then that proton could have been made 10 to the 34th power years ago. So the universe can be, not only can be, but is infinitely old. The same thing goes for black holes. You can't build a black hole in one generation of star formation. You can't build it in 2 generations. You can't even build it in 1 trillion generations. So the universe has to be infinitely old. since we have supermassive black holes. And since we have indestructible protons, it is also can be old, infinitely old. Anyway, what I say is that indestructible sacs, electron sacs, and electron sacs is spit out of an indestructible nucleon sac. So a neutron spits out an indestructible electron and it becomes a proton, okay? So what I say is that since the discovery of neutron stars, I say that the neutronium in a neutron star is like a seed, okay? That star life, okay? They say that the neutron star is a dead star. Okay, what I say is it contains embryonic neutrons that when they warm up through the CMBR, embryonic neutrons below absolute zero. Now, temperatures below absolute zero is a whole other topic, okay? So let's make sure we got the concept of how energy is stored inside a nucleon sac, and it's permanently stored. So we really only need to be concerned about 4 sacs because there are only 4 known mass energy vessels that can permanently store both mass and energy. And I say that the mass inside a proton mass energy vessel sac is compressed God particle once, okay? And that the generation of electromagnetic waves is the harmonized pulsation of these sacs, okay? That nucleons and protons, that they pulsate and that they hover, okay? So nucleons and protons do not touch in the nucleus of an atom. They hover, okay? The electron is given as hovering around the nucleus of an atom, okay? So anyway, they pulsate, and these pulsations are what makes electromagnetic waves. And when more GP1s are imploded inside the sacs, then space is compressed into a lower volume, okay? And this is what creates a flow. So there's a flow, matter creates a flow of God particles to the center, okay? Matter creates a flow of God particles to the center, and the way to view the Earth is a low GP1 ether pressure system. The way to view the sun is a low GP1 ether pressure system. There's higher pressure out in the universe, and you need that higher pressure in order for electromagnetic waves to propagate. And because electromagnetic waves propagate throughout the universe in the cosmic microwave background radiation, we know that pressure is high, okay? Because electromagnetic wave compresses GP1s and decompresses. And it does it 160.3 billion times a second, okay? That's a lot of compression. So the pressure is much higher for the GP1s in the universe than it is at the center of our, and then these low GP1 ether pressure systems, like low air pressure systems on Earth, they combine to bigger systems, okay? So that's how, so the Earth has a GP1 accretion disk, and it's those GP1 striking our bodies that create gravity that pushes to the center of the Earth. Now, GP1s going towards the center of the sun that strike Earth is what keeps us in orbit around the Earth. And that this is an invisible accretion disk, okay? And in conservation of energy, when you're generating gravity, you're storing dark energy, okay? Now, the end product is how the cosmic web forms, okay, is that the overdensities, the shape of the attractor is going to heat up. It's going to heat up till it can't heat up no more. And then the neutron stars and the black holes, they will cool. The cooling, more GP1s will be, as matter cools, it's going to expel more GP1s and create dark energy. Okay, so what the dipole repeller does, the dipole repeller void that is pushing us towards the normal cluster at 290 kilometers per second, what that void is doing, it's the matter sacs are cooling from the cold neutronium in neutron stars and black holes and white dwarfs. It's cooling, and that cooling of matter net expulses GP1s, and they make up the structure of space. So that's why our local galactic group, the Virgo cluster, are all moving towards the normal cluster, are being pushed, okay? It's a duel. We're being pushed at 290 kilometers per second by the dipole repeller, and we're being pulled by the shapely attractor at 341 kilometers per second. So we're moving, we're flowing into this ocean of GP1s, God particle 1s,